Welcome back to the deep dive. So, for the last, 10 years, if you've been in front-end web development, your whole world, your job interviews, your entire online life, it was all dominated by just one question.
React, Angular review.
Exactly, the framework wars. But the stack of source material we have in front of us today suggests that entire conversation is basically becoming obsolete.
It really is.
We are staring down the barrel of the biggest foundational shift in front-end dev in a decade. And the battlefield, it's just not between frameworks anymore. It's between the frameworks and the browser itself.
And that is the absolutely critical takeaway we pulled from these articles. For so long, developers felt they had to pull in a massive JavaScript framework just to build something, serious.
Something modern and performant.
Right. And that necessity created an entire industry, these huge centralized ecosystems built on proprietary logic. But what the sources are arguing is that necessity is just evaporating.
How so?
The standard browser platform that made the native APIs, the web components, they're finally maturing. And they are essentially eating the framework's lunch.
So this isn't just about some minor browser updates. We're talking about the browser actually growing up and systematically absorbing the superpowers that used to belong only to the frameworks.
That's the perfect way to put it.
So our mission today is to give you the shortcut. We're going to unpack exactly how these specific native APIs are replacing those features and why you should start treating the browser platform like a real first-class operating system for your apps.
Because the destination, as this body of work defines it, is a simple one. Frameworks are moving from being a total non-negotiable necessity to just a customizable preference.
Let's get into it.
To really get the scope of this, you have to look back at why frameworks became so utterly dominant. It wasn't, arbitrary. The early web, as our sources put it, was this messy bazaar of competing specs, half-broken implementations. If you were building a dynamic app back in, say, 2010, the web platform was just not ready for what you needed to do.
Okay, so let's unpack that history. When a developer decided, I absolutely need Angular or even jQuery back in the day, what were the most critical building blocks that were just genuinely missing from the browser?
Oh, almost everything that defines a modern single-page application, or SPA. The browser could, render HTML or write a few scripts, but if you wanted fluidity, consistency,
the component separation,
all of it, you're completely on your own. You needed reliable, standardized solutions for app-level concerns. Things like robust routing, predictable state management, easy templating, and maybe the most important thing, component isolation and lifecycle management.
The native platform just gave you raw tools. It felt like you were programming the metal, not building an application.
Exactly. And that gap, that chasm between what the browser offered and what developers needed, that is precisely where React and its predecessors became heroes. They didn't just fill a void, they promised order in the chaos.
But their solutions, while brilliant for getting things done, they were often just, clever hacks?
Clever hacks, expensive stopgaps.
Yeah.
They were designed to mask the browser's own deficiencies. Take React's virtual DOM. We talk about it like it's some kind of magic, but what was it, really?
An abstraction layer.
Just an abstraction layer. It was created to solve the excruciating pain of manual, slow DOM manipulation in legacy browsers.
Can you elaborate on that pain point a bit? I mean, why was touching the native document object model so hard that we needed a whole separate layer for it?
Because the native DOM is slow. Every single time you make a change, the browser might have to recalculate the whole layout, that's called reflow, and then repaint parts of the screen.
And in older browsers, that was a total performance killer.
A nightmare. It was unpredictable and computationally heavy. If you tried to update 10 different things one after another, you could just grind the whole app to a halt.
So the virtual DOM was this brilliant hack because it batched things.
It batched everything. It would figure out all the changes in memory first, and then apply the smallest possible set of updates to the real DOM in one go. It made the app feel fast, even when the underlying tech was sluggish.
So it was a productivity tool, but really it was a performance patch for a substandard native environment.
Precisely. Or look at Angular's two-way binding. It felt magical, right? Change the view, the model updates.
Instantly.
But as our sources highlight, that often led to cascading chaos at scale. Debugging state changes was a nightmare because you had no idea which binding triggered which update. It created what our sources call spaghetti architecture.
Okay, so the big implication here is the architecture they settled on.
Yes. They built these sophisticated systems, these castles on sand, using all this indirection to shield developers from the bad parts of the browser. But now, The browser vendors are paving the ground beneath them with solid native features.
And that shrinks the need for all that complex indirection.
It does. And this foundational shift, the sources argue, is going to dramatically simplify code upkeep and just reduce developer toil.
Which brings us to today, and this is where it gets really fascinating on a technical level. So if frameworks filled those voids with their own solutions, VDOM, custom routing, what specific native standards are coming out now that can compete?
And not just compete, but in some cases outright replace them. The browser is finally devouring the cake, slice by slice.
So what's the first slice?
The standard web platform has become incredibly focused on developer efficiency. I'd say the first huge step was encapsulation. Standards like Shadow DOM, part of the Web Component Suite, now give you true component encapsulation.
So this isn't just simulated CSS scoping done by a build tool.
No, this is the browser creating a genuine boundary. Outside CSS and JavaScript literally cannot leak in.
And that's critical because component isolation was always one of the biggest reasons to reach for a framework. Without one, you are stuck with these elaborate CSS naming schemes just to stop your sidebar from breaking your footer.
Exactly. Now the browser just handles it. Then you have modules. ES modules solve that dependency spaghetti of managing dozens of script tags.
In the right order.
Oh, what a nightmare that was. Now we have native imports and exports right in the browser. You don't need Webpack for that basic structure anymore. And for core utilities, I mean, async programming is now seamless.
Right, with fetch and async await.
Fetch, async await, streams.
Yeah.
It's all standard. Think back to having to use bulky polyfills or that clunky XML HTTP request object just to make a network call. Now it's built in. It's clean.
Okay, let's talk about the biggest one, application navigation. How is the browser tackling high-performance client-side routing? That was always the jewel in the framework crown.
It was. And the browser has released two incredibly powerful new APIs here, the Navigation API and the View Transitions API.
Okay.
Before this, frameworks had to use this awkward history.pushState API. It was a hack that let them change the URL without a full page reload, but it gave you zero control over the visual transition.
It was all function, no form, a jarring change without any elegance.
Precisely. The Navigation API replaces those clunky history hacks. It gives you a proper central place to handle client-side routing events. But the View Transitions API, that is the game changer.
How so?
It lets developers define how elements morph and move between views. You can have these truly fluid, native app-like transitions, smooth fades, slides, shared element transformations, all driven by the browser's super-optimized rendering pipeline, not manually computed JavaScript.
And this is still happening, right? This isn't over.
Not at all. Reactive primitives, people often call them signals, are now landing in standards discussions. Frameworks like SolidJS and Vue made this idea popular, this fine-grained reactivity. Now that concept is being generalized and baked right into the browser's DNA.
So if you put all that together, native component isolation, native modules, fluid routing, standard state primitives, the platform starts looking less like a blank canvas.
And more like a mature, first-class operating system for web apps. And the sources confirm this isn't just theory. Major organizations are already using these native capabilities to slash their bundle sizes and cut down on maintenance debt.
Okay, while those native features sound like a death knell for frameworks, let's take a critical pause here. If standards are objectively getting so much better, so much more performant, why is React still king?
And why aren't companies just throwing out their frameworks tomorrow?
Exactly. It would be lazy to assume frameworks are finished overnight. So what real problems do they still solve that native standards, in their current state, don't?
And this gets to a really important point about the difference between tools and process. Native APIs give you the high-quality building blocks, but they don't give you the instructions for the cathedral.
I like that analogy.
Frameworks, on the other hand, they excel in three crucial kind of non-technical areas. First is conventions and architecture. Standards are flexible. They're minimal. They don't tell you where to put your state or how to name your components. A framework provides an opinionated structure.
It forces conventions.
It forces conventions that, even if they're annoying sometimes, they provide predictability. On a large team that saves countless hours of debate, a new hire can be productive on day one because they know the rules of the road. It's a massive productivity multiplier.
So standards give you freedom, but that freedom can lead to architectural anarchy in a big team. Frameworks impose discipline.
Perfectly said. Second, we have developer ergonomics. Newer frameworks are constantly innovating on the experience of writing code. Celt, for instance, is this super efficient compiler that abstracts away stuff you might have to manage manually with native APIs.
They can experiment faster.
Much faster.
Yeah.
They can minimize boilerplate, simplify syntax. They can move in a way that slow-moving standards bodies just can't. The development experience often still feels much smoother inside a polished framework.
And the third area?
The massive ecosystem and enterprise lock-in. We can't ignore corporate inertia. React has a tooling base, a library community, a decade of training material. It's unmatched.
And enterprises love Angular for that reason.
They love it. It's the full battery-included solution. It makes decisions for you, and it has Google's backing. This sheer volume of mindshare ensures stickiness, even if the original technical arguments are eroding.
So the whole definition of need has basically flipped. 10 years ago, you needed a framework for the technical capability. What are you paying for when you adopt one today?
Today, you're paying for opinion, for structure, a predefined tooling chain, and guaranteed compatibility within a huge ecosystem. You're paying for conventions that simplify collaboration, not for patching missing browser features.
So they're moving from being required infrastructure to highly opinionated tooling.
Exactly. Tooling layered on top of a now capable web.
Okay, let's really drill down on the performance argument. For years, developers accepted this trade-off. Bloated bundles, heavy runtimes, a slight performance hit.
Because the productivity gain was worth the cost.
Right. But our sources argue that the performance gap between native and framework solutions is now so stark that this cost is getting really hard to justify.
It is. It's getting very difficult because the framework overhead isn't abstract. It's a measurable runtime cost. Custom elements, web components. They render faster than many VDOM abstractions because you're cutting out that layer of JavaScript indirection.
The browser is just natively optimized for what it does.
Of course. And shipping a full framework runtime just to handle something the browser can now do natively, like routing, that's becoming an unforgivable liability, especially in a mobile-first world.
And it's not just JavaScript, is it?
No, we're also seeing high-level CSS capabilities replace complex JavaScript. CSS container queries, for instance. They let you style something based on the size of its container, not just the whole viewport.
That replaces a whole class of layout hacks that used to require brittle JavaScript.
Entire classes of hacks. It kills the need for resize observers and heavy logic. Native is just inherently more efficient.
But this isn't just a technical problem, it's also political, isn't it? Standards have better performance, but frameworks have way better marketing.
Oh, absolutely. Frameworks are backed by massive, well-funded corporations. Meta, Google, they have dedicated teams pushing polished documentation, constant updates, aggressive marketing.
Well, standards are slow-moving committees.
Exactly. They're slow-moving W3C or WCAG working groups. They're consensus-driven, they have no unified marketing, and the implementation timelines can vary wildly across browsers.
So the standards movement has a severe PR problem, even if the tech is better. How do they overcome that inertia?
The challenge is immense. I mean, frameworks iterate in months. Standards iterate in years. Now, what's interesting is that standards are now being explicitly designed to compete with framework features, often borrowing the best ideas like signals.
But there's a deep cultural inertia.
A huge one. Universities, boot camps, they build their entire curriculum around teaching a specific framework, not the underlying web platform. Job listings demand 3 years of React experience, not 3 years of navigation API mastery.
That's a great point.
So until there's a massive educational shift, until the standards bodies can provide unified, excellent documentation that matches the corporate backing of frameworks, developers will keep choosing the familiar path, even if it means shipping a bigger, slower app. We're fighting decades of habit.
So what does this all mean for you, the developer, and the apps you're building right now? The final thought from the source material is pretty provocative. It's stark. Frameworks once saved the web from its own problems.
But now they're starting to look less like saviors and more like middlemen.
Necessary middlemen, maybe. And clinging blindly to that framework-first mentality risks shipping bloated, outdated apps while the rest of the web is racing ahead.
The conclusion from the sources is really undeniable. The standards movement is the sharpest and most feature-complete it has been in decades. It is time for every single development team to fundamentally reevaluate their reliance on huge framework runtimes.
The browser is now a powerful, capable environment.
And ignoring that shift is a significant business risk.
Which leaves us with a provocative thought for you to chew on. If native APIs are now providing high-performance component isolation, reactive primitives, and fluid native-like routing, how much longer can the argument for productivity gains really justify, including an entire heavy framework runtime?
Is the true future of web development genuinely Zero framework, relying only on standards? Or will frameworks just evolve to become tiny, optimized compilers?
Just tools that handle the developer experience and conventions before compiling down to pure, standards-compliant, zero runtime code.
The choice between necessity and preference is now yours.
Thanks for joining us for this deep dive.
We'll see you next time.